So this is a problem that we didn't get to in class yesterday, so let's look at this one. The flip grid did a great job. I just wanted to emphasize a few points. First of all, look at point C. It's straight across from here. So don't you think C and B have the same y value? Yes, they do. They have the same y value, and so the y value is y sub 2. Likewise, look at C and A. Don't they both have the same x value? They do, so let's make the x value the same for point C and call it x sub 1. So this is the coordinates of point C. So we're supposed to find an expression for the length of all three sides. So let's do that. This side here, let me see, they have the same x value. They're just going up and down. It's going from y2, or from y1, let's say, down to y2. So we can actually subtract numbers to find that answer. So like if this were, let's say, going from 8 to 3, we can subtract to know that the distance is 5. So you could do the same thing here, y1 minus y2. There you go. So that's this distance. Likewise, we can subtract to find the x's. So x2 minus x1. Okay, now here comes the fun part. The fun part is we have to find the length of the hypotenuse. So that is c, so we can use c squared being a squared plus b squared. Okay, and a, let's call a the x's, x2 minus x sub 1 squared plus, and then we'll have y, and I'm gonna switch these around to y2 minus y sub 1. That would actually make it negative, but since we're squaring it, it doesn't matter. Okay, that's c squared. And now we can take the square root of both sides. So let me do that by just drawing this square root sign there. This is the expression for all three sides. This might look familiar to you. Some of you already know this, that this is the distance formula. It tells you the distance between A and B. So in this problem, we're supposed to find a point that's the same distance from 3, 0 as it is from 7, 0. And the first point I thought was kind of easy, just halfway in between, it's 5, 0. But we're supposed to be able to find lots of examples. And maybe you did this, but you can find this is the same distance. Look at that distance, it's the same as that distance. This distance is the same. All of these points are the same. As a matter of fact, I don't even have to go on the lattice points. The lattice points is where the grid crosses. So every point that's on this vertical line is the same distance. So how does configuration relate to the 2 points? Well, this is the line that's halfway between them. And we're going to learn a word for that soon called a perpendicular bisector. For this problem, we're going to see if these side lengths are all the same. And I'm going to mark that. So if I put a tick mark there, then that tick mark shows that these two are the same. So we're really wondering, are these all the same? And the answer is yes. We can see that by drawing our triangles so we can find the length of each side. This one has a side length of 2, so that's B. Side length of 1, so that's A. So A squared plus B squared is C squared, so C must be the square root of 5. And if you look at the other triangles, they all have the same dimensions. They're all 1 by 2 triangles. They all have a side which is 1, another side which is 2, and they're all right triangles. And that holds true for this triangle, and well, all of them really. So we just proved that this is equilateral. So the answer is it is equilateral, but not equiangular. It's not equiangular because this angle looks very different than this angle. The hardest part about this problem, in my opinion, was figuring out how to, what was the directions we're saying and how long each of these segments are. So this is a 20 by 20 square, and since P is marked 8 units away from A, and all these other units are the way all these other distances are measured this way, I think as soon as you draw the diagram, things get easier to figure out, because now, since the whole thing is 20, this section from A to S must be 15, so they adds up to 20. The 12 and the 8 add up to 20. This is another 15, and there's another 12. So once you do that, we're going to try to find the lengths of the sides of the quadrilateral. And we have a triangle that we can use to find the length of the sides. We can either use this triangle with side lengths 5 and 12, or this one also has the same side lengths, 5 and 12. And we could find that side length is 13. We can use the same thing in the other triangles, 8 and 15, and we get C, something like that. So the last question is there anything special about this quadrilateral? And it certainly looks like it could be a rectangle. Boy, we should talk about that. I'm not going to give it away now. So this goes back to the problem that we unfortunately didn't have time for yesterday, but one way that we just discovered yesterday, well, if we would have talked about it in class, it would have helped, that you can use a distance formula to find the distance between A and B. And the distance formula is the one that is the square root of those two things squared. The other way, and the way that I actually like, I don't like memorizing formulas. I don't like using them. I make too many mistakes. I like drawing a right triangle and using Pythagorean theorem. So we can figure out how long A is, we can figure out how long B is, and so we can find C. So to me, that's the preferred method, but everyone can do whatever they want, and sometimes it is convenient to use the distance formula. Those are two ways. So we're supposed to find if point P is the same distance away from A as it is from B. So we're going to try to find these two distances, and we'll see. So here's one distance that we're going to try to find. Here's another distance. Again, you could use Pythagorean theorem. This is 2, and this is 1, 2, 3, 4. So we can use Pythagorean theorem to find this distance, AP. And so the distance there is square root of 20. You can get a decimal approximation, or I simplified it to be 2 square roots of 5. And you notice that that is the same as this one, because yeah, the triangles are the same size. They both have a side leg of 2 and another leg of 4. So now the question is, can you find other points that are the same distant, that are equidistant from A and B? And I think you can, because you can find a point in the middle. That's another one. And then, and one way you can check is, once again, you can find the distance, but even if you just look and see this is 1 and 3, this has a side length of a leg of 1 and a leg of 3, you know that those two triangles are the same because they have the same triangles. And let's try to find yet another one. So once again, I'm trying to look for triangles. Here's one, goes there's a triangle going this way. These are both 2, 1, 2, 3, 4. This is 2. Hey, those are 2 and 4 triangles as well. So we found a couple other points. Let's got to find even another one. Do you kind of notice a pattern though, that these points are kind of lined up in a line? And we might be able to use that pattern to find another point. So maybe something else is on that line, like some other point on the line. Maybe this one has the same distance. So this is a triangle which is 1 and 7, and this one is 5 and 5. Hey, we happen to know that that one does work. Those are both the square root of 50. We did that before. So those are some points. Can it be found in every quadrant? Well, it looks like we're kind of missing one quadrant, or missing the quadrant over here that I don't think our points are ever going to be in that quadrant. So I think they could be in 3, but not 4 quadrants. For this problem, we're going to find 2 points on the line y equals 3 that are 10 units from point A. So let's draw this. It's going to be 10 units as the crow flies. We talked about that yet a couple days ago. And this is 10 units here. And we can make a right triangle, so we can use Pythagorean theorem to figure it out. Okay, down here we have, this is at -3, but this line up here is at 3, so this distance we can just count, or we can subtract. 3 minus -3 is 6. I could have counted to get that. And we're trying to find how far away this point should be from this spot right there. So this is a distance that we're going to find. So let's use Pythagorean theorem. So using the Pythagorean theorem, we found that x, which I called b, is going to be 8 units away. So my drawing was pretty bad. It's going to be 8 units away. And if we're starting at 3 and we have to go another 8 units, we're going to be over here at 11. So the final point is over here at 11. Sorry about the mess up here. And if we're going to go 8 back this way, then we start at 3, we go back, we can take and subtract. 3 minus 8 is -5. So here's where that point is. So the 2 points are -5, 3, and 11.